Yeah, I think we're going to start now. It's already 10 minutes past and there's no need to waste additional time. Good evening, everybody. Can we hear me loud and clear? If you can hear me, you
Yes,
can
we can
indicate
hear you.
with by reacting. And welcome to this first session of Airsoft Marketplace with Schema Cloud, where we'll be looking at things around data engineering. And then we're also going to be looking at we're going to be having more sessions in the future. Today's session is not just going to be the only one. We'll be having more sessions in the future. And we look forward to seeing all of us in those in that session. So without wasting our time, I would like to just do a brief introduction about myself and then we can get started because we're already 11 minutes behind. My name is Oluwasegun Haziz. I'm a software engineer that has always worked with data for the past decade. However, I never knew about what data engineering was because what we just did was to gather data and just put it on a dashboard. But as I grew in my career, I understood what data engineering was, and then I had to branch over and check out into the data engineering role to be able to help meet the organization and help the organization to grow and meet the needs of the business. And that role, it's so unique to all business that everybody wants to have a pile of it and everybody wants to ensure that they have a data engineer in the team and in the organization. And that's what left to us having this session where we look at introducing us to data engineering and how it relates and how it helps us to have a business or a better business insights. And my first slide tonight is going to be on what are we going to be covering in this session. So what we'll be covering in this session is that we're going to be looking at what data engineering is. We are going to look at the data for the journey for data. And then the third thing we're going to be looking at is the key building blocks. How do we get data? And then the fourth one would be real world scenarios, where we look at about four to five examples of how data help the business to make better decision and have a better business insights. And the fifth point will be working with data teams, and then the sixth point is how to get started. Um, Before I tell you about what I put in my slide, if you have ever wondered about cooking, especially when you want to cook, if I give you a lot of ingredients or a lot of things to make stir fried spaghetti or those special indomies we make at home. Um, you would have different imaginations. So where I have carrot, I have a bell pepper, I have egg, I have meat, I have the spaghetti, I have various ingredients available for you. You'll be able to think about different aspects of things you want to do. However, if you get late at night and you could only see spaghetti, pepper, and you have three eggs left in the crate, the only thing you think about or you want to do at that point in time is to cook concussion spaghetti. Just get something done and get moving. Or if it's noodles, you just want to cook plain noodles and put the normal ingredient that comes with it and boil the egg and go with it. Now, the issue you had there is not the noodles or the ingredients there. But the issue you had that differentiated you from cooking a special kind of spaghetti or noodles with all the different accessories added to it, with just cooking plain spaghetti and plain plain Indomie noodles is because of what you have available at that point in time. It was late at night, and then you needed to make a decision. You can't go out to buy more ingredients to be able to cook the special kind of noodles or spaghetti you want to cook. And same thing applies to us in business. The kind of data that we have access to help us to make business decisions. For example, if I post on TikTok or Instagram or social media, and the only thing I'm always seeing is the number of likes, the number of comments, and all of that, I would say I'm doing well. But if I tell you that those people interacting with your post on social media, their demographic age is between 18 and 30 years old, that would intrigue you, and you will start thinking towards what are the content I can create for people between 18 and 30 years old that will help me grow my account. Now, data is helping you to make a decision. And then if you want to capture people in the age 40 years and above, people will call adults. That data you currently have is telling you that what you're currently posting does not speak to people 40 years and above. So you start looking for how to make posts that affect them. You look at how to make content that affects them. The data you have determines how you now make those decisions. Now, one thing that we've discovered when I was doing my research is that in 2025, since 73% of company data that they have, it was never analyzed for them to have business insight or to make better decision. Then every day, 3.5.1 hours is lost because company have access to bad data. That means nobody in the company tried to clean the data and then ensure that the company has better data to make decision. And then 12.9 million on an average cost is lost due to poor data quality. Just like I have said earlier, if you have access to better data on your social media posts, it will help you to structure how you want to and the kind of target market you want to reach and how you want to make money and how you also want to make posts. Now, data engineering is now the infrastructure that helps take all of the data that are available for a business for them to make it to have a better business insight and also to have a better business value. For example, if I'm selling food, and then I discovered that through my ordering platforms or child deck or social media, people that reach me in my DM, and the age of people that are ordering those foods are between 20 and 35 years old. I would want to focus my attention based on the data I have in how I can continuously serve those people with reduced price by giving them quality food. Because I have data, I'm able to make that decision. Now, imagine in my food ordering, the people that are ordering those foods are people that are 40 years and above. I will want to give them options of healthy meals where they have less carbohydrate foods and more protein, more vegetables, or give them the option of ordering in bigger containers, maybe for family of 5, family of 10 every week. The reason why I'm making that decision or I'm making that statement is because I have access to data that is telling me that my business or my audience or my target people, this is their behavior or this is their demography. That now helps me to now make better decision. The next slide is now I want to look at what a data engineer is by trying to give us a textbook definition. And the first thing I put there on my left side is trying to think like a plumber, where we try to get water into a building. So the plumber needs to lay pipes around the whole building. Sometimes they hide those pipes inside the wall, sometimes it's external. depending on whatever they feel like is the best thing. So a data engineer is just like a plumber that helps to go and get all the data that the business can use to make decisions from different platforms. And then now do what? It now build a system that collect those data from those different sources. It can be from social media platforms. It can be from the application you are using or the app you've or the products you've built, how people are interacting with it, and how people are now ensuring that people are now using it. Now, it doesn't just build those pipelines to collect the data from different sources. A data engineer also ensure that the data is clean and is trustworthy. The data is clean, the data is organized, and is also trustworthy. If you go back to the case of the plumber that builds, that allows that gets water into the building, he also wants to ensure that the water that is coming into the kitchen is clean, and the water that is also going to the bathroom for bathing is also clean. It won't just send different water. It won't send unclean water into the building. It will ensure that if it has maybe taste, there's something filter that would be put there to help clean up the water, maybe due to the location. So what that plumber is doing is trying to give the house a clean water and also organizing that water so that it won't have maybe taste or different thing where the water will now be said that is not of good quality. So also is a data engineer. He wants to ensure that the data that is coming for the business or that the business have access to is clean and is also organized in a way that is trustworthy. Beyond that, a data engineer also delivering it reliable to the people who need it. So the data he has gathered, he wants to ensure that the people who need it are able to have access to it on time and in a very secure way. It keeps it secure, it makes it fast and scalable. For example, I've worked on one where at every 8 a.m. in the morning, somebody wants to get the report. So as they're resuming in the morning, the report is ready for them to view on the dashboard. So it is my job to ensure that the data that they need is run without me waking up or me stressing myself. And maybe at 2 a.m. or 3 a.m., the data is being fetched into the system and they are able to get the water without me being there. Do we understand what this means thus far, or do you have any question? If you understand it, let me see you react with any of the emojis saying, yes, I understand. And if you have any question, you can type it in the comment section and in the chat, and I'm going to read it out. Good. Now, I hope you understand how you can get data for your business to be able to have better insights. The next thing I want us to look at is the data journey, how we get data from our different sources and then get it into the business setup for the business to be able to get access to this data. So the first thing we'll do is to know where our data is going to be sourced for. For example, if I'm running a food business, one of the places I can source for my data is social media, Facebook ads, Instagram, Twitter, whichever platform, TikTok. Or if I'm selling clothes, one of the places I can source for my data is social media. If I have a product, maybe I work in the bank, I want to ensure that I have data on not just who is carrying out transaction or the amount of transaction that was carried out today. I also want to look at what devices are people using to carry out their transaction. Are they using their laptop? Are they using the mobile app on Android or using the mobile app on iOS? That is different data source. And for different organization, different our data source can differ. If I'm in marketing team, one of the platforms I want to get my data from is the CRM. Some people use Salesforce, some people use HubSpot, some people use different tools. So I need to know how to get that data out of there into my data pipeline or into my system. Some people use analytics to get data to say, oh, I ran an ad for 2 weeks on Facebook. This is the number of people it has reached. Or on Google, this is the number of people this data has reached. That data, you need to be able to continuously get it and give it to the business for the business to be able to use and make decision. Now, when you get this data from different sources, you want to do what we call ingest. That means you want to build all those data from different sources. You want to build them together as one. This is where the core of data engineering work lies. You want to look at the different data that are coming from different sources, and then you want to map them together as one. For example, I've worked on set of data on Facebook and TikTok. On Facebook is on Facebook and TikTok. Now, if you make money from TikTok by selling a product, what TikTok gives you, the way TikTok gives you is called payments, paid payments, or something like that. But from Facebook, Instagram, what they called it is end amounts. The same type of data, but different variable name or different name for because it's coming from different place. Now, if I want to present that to my oga or my head of the management team, I have to match those two data together and give it a name saying revenue. And then they will be able to see, maybe I'll also create a new column saying this revenue today is from Facebook, the revenue from yesterday is from TikTok. They're able to see it. So we collect those data from different platforms and then bring them together under one umbrella. Then the next thing now is we want to transform that data. We want to clean it, we want to shape it, and we want to enrich the data to meet the business requirements. If I'm in the bank, in the financial institution, the data I'm working with in the financial institution, I want to look at what are the successful transactions that was carried out every day, the volume of the successful transactions, what device are they using, what accounts are active, what accounts are inactive. Now, if I have all of those data that is cleaned and I can see it on my system, I can do a marketing ad that targets people that haven't transacted on our system, saying if you do if you do up to 5 transactions in a month, the sixth one would be free. I won't charge you, there will be no bank charges. That is how the fintech started growing in Nigeria. And everybody started using OPay and those different platforms. Why? Because they stopped charging us bank charges and then they seem to be more reliable, no network failure. So everybody started putting their money there and people started recommending them. Why? Because they look at what is the bank doing that we can give people that people would benefit from. So they started giving us free transactions. We don't need to pay for transaction. Neither are they also charging you for SMS charges. So how are they able to do that? They use data. That out of 50 million people carrying out interbank transaction every day, if I'm able to get 10% of 50 million people to be doing that on my platform, which is 5 million, I will be able to make money. I will be able to grow my platform. So what data engineer help us to do is to now transform those data, clean it up and enrich it so that we'll be able to present it to the business. Now that you've done all of this, there's also one thing you need to do, or you ensure that you do. You ensure that your data is being stored somewhere so that when it is needed, the business can make use of it. So you need what we call data warehouse or data lake. What that is just another technological tool that has been built for you to keep data into the system. And once that is done, the last leg is now data dashboard, where we have the data analysts, where they are able to use Excel, Power BI, and different tools to give the business graphical representation of their data for them to now have access to the data all the time. And you can go and sleep once the data is being fetched and there is no issue with any pipeline broken. You'll be able to go and relax and just come to work and enjoy yourself. So that is the journey of data from source to have it as an insight for the business. For some people, their data is being fetched every 20 to 24 hours. For some people, it is real time. So depending on how the business is being run. The next thing I want us to look at are key concepts of what is run in the data pipeline. Now, you remember I used the concept of the plumber running water from the borehole or from the tap into the house by running different pipes with different pressure. It's also the same thing for a data engineer. We have the data pipeline. And what is it? Is a data pipeline is an automated sequence of steps that move data from one place where you've gathered all your data. I've mentioned CRM, the products, database, social media platforms, wherever your data is. You gather all of them from one place, you collect it, you clean it, and you deliver it without manual work. When I say without manual work, going back to the example of a plumber, a manual work is me carrying bucket of water from ground floor to the third floor. But a pipeline is me getting home and I need water. I live on the third floor. I open the tap and water rushes out without any obstruction. That is what I mean by without manual work. That also means that as a data engineer, you must never update any data. You must never edit any data. As it is coming from source, you also present it. The only thing you do is to um, transform by cleaning up and getting the required data because it's not all data that is coming from the platform that is needed for all the time for the business. So I thought I gave another example of it there. And I also said that why it matters for you is that without a pipeline, someone has to manually export a file, paste them into spreadsheets, and hope they didn't make mistakes. Not everybody know how to use the Excel spreadsheets. So when you manually enter data, some data are going to be properly formatted. Sometimes they are not properly formatted. So the job of a data engineer is to make sure that nobody is doing any manual process in getting the data and also presenting the data. I put here that pipeline eliminates the risks that gives you eliminate that risk and give you an up-to-date data automatically. So you look at extract, pulling the data from source, you transform it, clean and reshape, and then you load, store it centrally, which is loading, and then you deliver it via an API to the data tools like Excel for some organization, Power BI, Tableau, whichever one the organization is using or the business has set up. Now, the next key concept I want us to learn is where does data live? You would have heard of words like data warehouse and data lake. And I try to differentiated that. A data warehouse is where a structured, clean, and organized data, predefined format lives, optimized for faster querying and reporting. So this is basically where a data engineer stores his data so that the business analyst and the business team or the management that need access to those data can go pick it up and have a better insight into the business. And then I put here that they are best for business intelligence and dashboard, constant KPI and reporting, and then finance and operation analysts. Examples of these two are Snowflake, BigQuery, and Redshift. They are just tools that are used to help us to get and to store data. They are attached to different clouds. This is not this session is not a session to look at tools. It's just to introduce us to what data engineering is. Now, data lake looks at raw unprocessed data in any format. It can be images, it can be text, it can be logs, it can be video, whatever. And they use cheap storage to keep those data. That means they are unprocessed data, they are raw in a raw state, but we need them. An example of that is YouTube data. When you look at YouTube data, how does YouTube know that this video you uploaded, 2 million people watched the first 2 minutes? Another 2 million people watched the video to completion. They use concept of data lakes to analyze your data. And I put in here that this data lake data are best for machine learning and AI model training. They are also good for storing up data before knowing the use case, meaning they are already in their raw format. We need to now start looking at it for us to be able to know how to make use of them. And then they are also used for exploring data science. I also now put examples of where these data are being stored. Amazon S3, Azure ADLS, and Databricks. The next concept I want us to look at is data quality. It's very important because without equality data, you'll be making the wrong decision as a business. Now, what does data quality do for us? I remember when we were learning computer in the early 2000s, we used to have what they call garbage in, garbage out, GIGO. What that basically means is that whatever you give the computer is what the computer will give you back. And I put in here that the best dashboard that present data in the world is worthless if the data that is serving is wrong. So if I have made mistake in my data that I'm giving a business, the business will never make the right decision. Because the data that they have to make a decision is faulty or has been damaged along the line. When we look at data quality, we want to look at the concept of accuracy. That means that if I manually pick the data and what you have presented to me in the data pipeline, I want to compare, I want to see that they are accurate. So that means that, for example, if I have data on social media, for example, Facebook, if I go pick that data from Facebook and I export it out manually and I go through it, I run maybe through an Excel, the data you are presenting to me as a data engineer must match what I did manually when I go and verify it. So there must be accuracy in our data. And then I put here that does the data reflect reality? There must also be completeness, meaning there must be no missing data or skip data. A skip data is a data that actually exists, but somewhere along the line is missing. And I've experienced this before. with one of the fintech where transactions that are timed out were not in their database, but they exist. The third point I also put here for data quality is that your data must be consistent, which has also given an example. So your data that you're presenting, does it match across all systems? When I go verify manually or through using another system, does the data match each other? And then your data must also have what I call timeliness, meaning it must be up to date. If today is 3rd of June, and the company says they want to see data every 24 hours, that means I must see data up to 2nd of June. When I come to the platform, I will request data through a data pipeline from that the data engineer has set up. That data should not be telling me that the latest data that is fetched was in May. Between May and now, I need the data that's of the business. I want to know how the business is doing. So your data must be up to date, must be timeliness, must be up to date. You can't afford to miss that. Nobody works with obsolete data. The next thing I want us to look at are reward scenarios. Growing up, whenever we go to some stores, we always we encounter things like, oh, this product when you want buy, you don't finish. Supplier never supply me. A data pipeline can help us to ensure that we don't run out of stock in a retail organization. So I put a case study, a problem, and say that the store managers do not know what's running low until it's already out of stock. I know some of us have experienced it when we go to those big shopping malls like ShopRite and Co. The products you want is out of stock, or even from your regular customer. They will tell you, our customer, they never supply us. Why? Because there was no way for them to track when the product is going to be out of stock and for them to request for more products to be sent to them. So, for example, if there's a proper data pipeline, we'll be able to track the sales transaction, the inventory level, and then the supplier time. How long does it take for them to supply them these products every time they request for it? For most people, it sits in a separate system because their system is not integrated. But if we have a data engineer that build a pipeline for them and has cleaned the data, there will always be products to sell every time in the warehouse or in the store. And what that means is that it will tell them ahead of time, maybe if we set it at 30% threshold based on what I have here, it will tell them ahead of time that you are getting low on stock, you need to request for new stock. And before they are out of stock, they will be able to get a new stock back into the business, into their location. Another reward example I also put here is real-time fraud detection. I think I put 5 examples here. The problem for fraud detection is that you want to flag every transaction that looks fraudulent. The problem I stated here is that some fraudulent transactions are flagged hours after they have happened, which is too late. Or sometimes it might be when the customer raised it up. Some of us that have experienced POS theft would be able to understand. Now, the data there is that we can track card transaction, GPS location, fingerprint, and the spending history. One way we can track spending history is if somebody is used to doing transaction of 100,000, 50,000, 150, 200,000 all the time, If we suddenly do a transaction of 2 million, we want to flag that transaction. Why? Because the customer is not used to doing a transaction in million. Then we can go and verify, customer, are you the one that carry out this transaction? So if we verify, we'll be able to say, okay, yes, he actually did carry out this transaction. Why? We were looking at his transaction history over the years to say, this might look fraudulent. So let's flag it. And if we do that in real time, we'll be able to reduce fraud. I've experienced my auntie where her card was doing transaction of 300K successfully in the space of 30 minutes and they wiped out the accounts. If there was a real-time fraud detection system pipeline being set up, they would have flagged it saying, why would this person be doing this transaction on a card, on a POS? Because she's not used to doing such a transaction. We can also look at it in healthcare, where we're trying to look at real-time gathering of data, health data. The diagnosis, in Nigeria, our healthcare system is standalone. You go to the doctor today, doctor says, oh, we need to go and do tests. You have to go to the test location, test center to go and do your test. The results will be ready in 24 hours, come back. So there's no real-time synchronization of all of the system. Because if there's real-time synchronization, once the doctor requests for a test, you just need to send it through the system. The lab gets it, the lab do the test, and once the test is ready, they don't need to tell you to come back after 24 hours to get the results. They need to just send it back to the hospital or to the doctor. And what that does is that it helps us reduce wasting time. I also have another example of e-commerce where we want to look at personalized recommendation. I know some of us would have seen a situation where you are thinking of something or you discuss something, a product with somebody, and then when you go to Instagram or you go to Facebook, you start seeing the ads. Sometimes nobody's listening to what you were saying. It's about the behavior of what you've been doing. Maybe you've constantly been looking at that bag on the Instagram page, and they kept tracking you that in the last 3 weeks you've been looking at this bag, maybe because you didn't have the money, and you are hoping that when you have the money, you will be able to buy the bag. And if they see a similar product or the ad of that same bag, they can send the ads to you saying, look at this bag, but instead of paying 75,000, you can buy it for 30,000. So that is some of the things we see in e-commerce. And then HR2 surveys looking at different warnings, employee behaviors, performance review, and leave pattern. We can set that to predict how an employee is helping the business to grow, or the best time this person works, and the retention of the business or the retention of employees in the business. Now, there are different landscapes and tools we use in data engineering. We have the injection process, which I've walked us through in the third or fourth slide. We have the transformation, and we have the different tools, as you can see on our screen. We have the orchestration, we have the storage, and we also have the visualization, which we're using the different BI tools for. But this session is not a session where we're looking at the tools or technical skills. We just want to understand the process of data engineering, how data is being sourced, and what are the things that goes along the line to get the data from the different platforms into the system. I'm almost done. The next is who does what and the data team explains. You would have had things like data analyst, data scientist, data engineer. What's the difference in between them? I try to explain that here. That a data engineer builds and maintains pipeline, gets the data into the warehouse and the data infrastructure. He ensures that the data is available, is reliable, and is clean. While a data scientist is looking at how they can use machine learning to build patterns or to make predictions from the data that they have. So it's basically building model and trying to analyze everything about that data and make decision to make prediction and answer complex questions. A data analyst is basically somebody that queries and analyzes the data to answer business questions. For example, the business can say, how did you perform in the month of May? A data analyst job is to go and look for all the data that is available for the month of May and present it to the stakeholders by building the dashboard. Oh, in this month we make X amount of sales. We have X amount of customers that still in us. We have X amount of customers that have paid. We have X amount of customers that didn't do transaction with us. All of those stuff. That's what a data analyst do, and then put it in a reporting format for their managers or the stakeholders. While an analytic engineer is basically the bridge between data engineering and analytics. They build clean data models that analysts can easily query. And where we see more of an analytic engineer is in the big industry, where we have huge amount of data. Energy, big tech industry, aviation, mention them, where we have huge terabytes of data. That's where we see analytic engineers more. Now, how business team can partner? Your first thing, I put a do and what to avoid here. I said define the question before asking for data. I've been in a situation where the business does not even know the kind of data they need. So as we are giving them the data, they started iterating, going back and forth, telling, oh, this is right, this is wrong, this is it, this is not it. So you need to define the question before asking for the data. You also need to document where your data lives and what it means so that people will not mix up the data. You communicate when the data source change. You need to ensure that your data source is not tampered with. You prioritize data that is being requested by the business because that helps to make a business impact. Build data quality into processes from the start, meaning at the beginning of the session, your data must have at the beginning of your data pipeline, your data must have quality in being added to it. Just like the example of the plumber, his goal is to send clean water into the building. So everything he needs to do, he must ensure that he's working with quality water. So also is a data engineer. We ensure that the data we are sending for the business is quality enough for them to be able to use. What are the things to avoid? Ask for all the data without a clear goal. I've mentioned it here that there are some data we don't need access to, even though we have it. Bypass the data thing with one of spreadsheets exports. I know somewhere they do this where they just want to have the data in Excel sheets. Yeah, it's good, but it's not the best. Never assume that the data is always right without checking. There should be a way to validate your data. Treat data engineering as purely as an IT function. That's like a pillar of the business. Never ignore data governance and security requirements because this helps to keep your data quality safe. What are the signs that your organization needs data engineers? The first sign here is because they are always familiar. Your analysts spend more time cleaning spreadsheets, not analyzing. I've seen situations like that where bulk of what they do at the end of the day is to clean up the data, clean it, or pad it. I call it data padding. They pad it until they get what they want on the Excel sheet or the spreadsheet. That's not a good practice. Different things, I've been in a situation where different things are quoting different numbers and for the same metrics. And then you'll be wondering, where did this one get the data? Where did that one get their own data from? Why? Because they don't have a better means of getting data into the business. I've also had situations where they will say, oh, I'll update it manually before any business review or before things like monthly performance review. That's not a good practice. You don't update data manually. It has to come from a source. I've also mentioned it in this session that you don't update, you don't edit data. You leave it the way it is, you present it the way you've gotten it from the source. Because when they do a validation on the data, it must be the same thing that they are seeing from the source. When your data quality incidents reach leadership before they are caught, we've been in meetings where we're trying to compare data and they are not making sense. So for organizations where we work that have different data in different sources, without having a single source of truth or single source of data to manage their data, that means you need data engineering to be set up. And then in a settings where your reporting is always behind, you are in June, you are still trying to analyze data for April. You're already behind because you've gone 30 days and some days into the latest data, and you need to have access to quality data and real-time data. How do you get started? A practical step. You need to have access, you need to plan, and you need to act. Audit where your data currently lives, identify your most critical business questions, and map which data would answer those questions. Plan, identify quick wins, which pipeline will save the most manual work. Define your data quality standard and what good data looks like. Decide build in-house or use managed data. And then act, start small, one pipeline, one use case, prove value. Hire of skill. You need a data engineer. Establish a data governance framework. That means what is the guideline of how you want to be getting your data? Things to remember as we round up this session is data engineering is basically the infrastructure. It's mostly not visible, but it's there. It helps you to do a lot of things. The pipeline is the product. A reliable automated data pipeline is more valuable than any one-off reports. Think of quality before quantity. You need to ensure that the data you are having is quality enough. Businesses that need quality data must also collaborate with engineers. We don't work in start alone. We don't work in standalone situations. We have to collaborate together. And then the fifth point is that you have to start small, prove value, and then you can then now scale. Any question? Thank you all. I put in where I got some of my data to be able to do this presentation in this last slide. If you have any question or anything, feedback, can this time to ask. If we also want clarity on one or two other things, it's time for question and answer. Okay, Sammy, you have your hand up. Please go ahead.
Okay, good evening, and
Good
thank
evening.
you for the insight. Okay,
Yeah, thank you, Mr. Shegun. Okay, yeah, sorry, go ahead.
hello.
Yeah, go ahead.
Okay, okay. This is I'm Sam, and I am currently doing my master's in research under business analytics. So now I'm a little bit confused of how or where I am
Yes, you
going
can.
to. Hello.
Continue, I can hear you.
Yeah. How am I going to bridge myself with this? I can see four different types of data, how to deal with data. I saw 4 types. So where does the business analytics fall onto?
So to me, a business analyst is still a data analyst. Why did I say that? A business analyst is the person that looks at the data and try to propose a roadmap or or a path for the business direction. And to be able to do that, you need access to data. However, if you want to go deep dive, get deep dive or deep dive into the data structure more, you can pick up data engineering to also get to know where data are being getting from or how to build your data pipeline. But if you want to remain as a as a business analyst, pick up data analysis too, where you are able to use tools like Excel to analyze data and to query data, and also tools like Power BI or Tableau, depending on the organization you are working with or whatever tool is available to you. And then
Okay.
you can also learn database too as part of it, how to query database and all.
All right. Thank you.
You're welcome. If you can't talk, you can type in the question in the
Yeah.
chat, and then I'll read it out. If you have any question, please raise
Yes,
up your
thank you
hand.
very much, Mr. Shegun, for this insightful class. Um, Data engineering is one of the most focused. Can you hear me?
Yes, loud and clear.
Hello, can you hear me, Mr. Shegun? Okay, yes. So thank you for the insightful lecture. We are going to continue this class for a very long time. Mr. Shegun is one of Haelsoft software engineer, and he works with us on all our big projects. So there's a lot that we're going to learn in data engineering, science, data analytics, business analytics, a lot you understand, and how we can use these different tools in our daily activity. Do you get? Every one of us needs skill. Do you understand? Whether in the legal aspect or an economist, if you are in that field, there's no need to understand how to use data tools. You understand about your business to get here. So thank you very much, Mr. Shegun. If there is no question, I believe we'll call it a day. I want to thank everyone that joined this class. This particular training is brought to you by Haelsoft EdTech. We have started our platform and we look forward collaborating with each and every one of you here in terms of